Hi, Mr. V. We're talking illustrative math, chapter 6 on coordinate geometry, distances and circles. This is a really fun lesson. If you log into the Desmos activity, you'll see we're going to talk about a number of things. This is illustrative math is our textbook. We're on unit 6 on coordinate geometry, distances and circles. By the end of this lesson, you would be able to derive an equation of a circle in a coordinate plane. And we start with this problem. Andre says, I know I can find the distance between 2 points on a plane by drawing a right triangle and using the Pythagorean theorem. But I'm not sure how to find the length of legs of a triangle when I can't just count the squares on the graph. Explain to him how he's supposed to do it, and then calculate between these 2 points the distance between P and Q. And when we do this, if I have my figure here, this particular problem will underscore all that we're going to do in the class today. This problem is typical for all of the problems that we're going to be doing. And if you were to read the hint says, it is not a giveaway, it says find the coordinates of n. In the x direction, left and right, n is the same as point Q. So it's going to have the same value as Q does, which would be 53. And in the y direction, it's going to be the same as P, which would be 12. And now, how far is it from here to here in the x direction? Well, if it's 8 units to get to P, and it's going to be 53 units to get to n, we're going to take our 8 and we're going to subtract it from 53 to get 45. So this distance would be 45. And this we'll call A. We can do the same thing with our y distance. I want you to think of it. Going from 0 to n is 12. Going from 0 to q is 22. And if I have 12 and 22, the difference between those two is going to be 10. So this distance here is 10, and that's going to be what we'll call B. So we do a squared plus b squared is equal to c squared, and we get c squared, and we get 10 squared plus 45 squared is equal to c plus 45 squared is equal to c squared. And when you add these and take the square root, you end up with c is around 46. It's not exactly 46. This is not a Pythagorean triple, but it's about 46 point something. And thus we find the length of the hypotenuse, making this a right triangle. The big deal was that you were going to take your 53 minus 8, and here we're going to take 22 minus 12. So if you were looking at the distance formula for on a plane between 2 points, the x direction, it would be your ending point minus your starting point. And it doesn't really matter which one of you do. If you did it backwards, if I subtracted 53 from 8, I would get a negative 45, but the distance is still going to be 45. So our next activity in this was the circle problem. This image is a circle, centers at 610. Its radius is 17. The point 1425 looks like it might be on the circle. You want to verify it. So 1425, if I draw my circle and I look at 14 in the x direction, would be about right here, and 25, is this point on the circle? That is my diameter, is my radius here going to be 17? Because we're told that the radius of the circle is 17. I'm going to make a right triangle. I know in the x direction, I'm going to go 14 units, and in the y direction, I'm going to go 10 units. So from 6 to 14 is 8. From 10 to 25 is 15. And now I can apply the Pythagorean theorem. A squared plus b squared is equal to c squared. I happen to know that this is a Pythagorean triple, so I can just look at it and tell you what the answer is. But if you wanted to work it out, you could, and you'd find out that c is equal to 17, which means that this point is on the circle. If it is on the circle, then this equation would hold true. We have a second one of these. It says, what about 22,3? Looks like it's on the circle. Let's do it. And I'll do the same thing. Use a different color. So 22,3 is the point I'm looking at. 22 in the x direction and about 3 is about right here. 22,3. In the x direction, my right triangle will be 22. In the y direction, it'll be 10. So to go from 6 to 22, this distance is going to be 16. This distance from 3 to 10 is 7. So again, I'll do my a squared plus b squared is c squared. I write the formula, substitute the values, and solve. Modeling for you best practices. And then when we substitute this in, we solve for c. Do we get 17? I think we get 17.46. What? If you round it to 17, it's 17. No, it's not. This length is going to be longer. So 22.3 is going to be just a little bit off. It's not going to be on the circle. So this is not work because the radius is not 17. Then we have this question, which is in general, can you check if a particular point is on the circle? And going further, this is the more question. I'm not going to go to the more question. I am going to go to this question, though. Here we have 610, and we have the point xy on the circle. I want you to draw the triangle and find out how you could find the length here. And that is actually the question to this one. How could you find it if xy is a point on the circle? So let's see if I can do this. I think I've already done it once here today. I'll just draw it on this circle. If I have a point xy that is on the circle, to find this length, I'm going to find my values in this way. My x direction, this is x. My y direction, this is 10. So how far is it? Remember, I told you we're going to take the absolute value of x sub 2 minus x sub 1. So here we have x. 6 minus x, I guess is what you could say. Maybe it's x minus 6. X minus 6 is in the x direction. That's going to be my a value. And my b value would be y minus 10. So if I take a squared plus b squared, I should get 17 squared. A squared plus b squared is 17 squared. And this is my radius, which is going to be 17. And when we do this, in this next activity, building the equation of a circle. Here, we're given an x and a y coordinate, and we're given -3 and 6. Uh-oh, this has got a negative value in it. What do I do with it? So you're going to come up with an equation, and then you're going to test it with 9,1, and then you're going to generalize it with hk. So we're coming up with we're doing the preparation for building an equation of a circle. And I'll do that here with this. Again, here's my right triangle. Here's my length. And here's my width. The coordinate of this point in the x direction, -3. The coordinate in the y direction would be y. And I need to come up with an expression for this length and for this length. For this one, I know that my y value is larger. So I'm going to take my y minus my y value here. This would be y minus 6. And in the x direction, this length, some people think it's going to be x minus 3, but that would not quite be right, would it? If I have my absolute value of x sub 2 minus x sub 1 as my length, and I put in there x minus 3, if this is -15, and I subtract 3 from it, I'm going to get that this length is -18. or absolute value of negative 18, which would be 18. What I want to do is I want to subtract a negative 3. So I take my original value x and I subtract from it negative 3. And if you take the absolute value, so if this is a negative 15, say it's a negative 15, I don't know if it is or not, minus a negative 3, negative 15 plus 3 would be 12. And that makes sense, doesn't this length? If this is 15 all the way across, and this is 3, we subtract 3 from 15, we would get 12. So this is my formula for the length here. It's going to be x plus 3, because I'm going minus a minus 3. I don't know if my explanation is very good. I want you to try it out and see what you can come up with. So I have a squared plus b squared is equal to, we're told that the radius of this is 13. In the problem, we're told that this is 13 squared. So this will be c squared. I should mark it as c squared and just substituting the values. Here we've written the formula, substituting the values, x plus 3 squared plus y minus 6 squared is equal to 13 squared. This is my formula. And now it says in the question here to substitute 9, 1 and see if it is on the circle. And it should be on the circle. 9, 1 would be like right here. So if I substitute 9 for this, I'll substitute the values. 9 plus 3 squared plus 1 minus 6 squared is equal to 13 squared. Here you have 12 squared plus a negative 5 squared is equal to 13 squared. This is 144 plus 25 is 169, and indeed that is what 13 squared is equal to. So this works. It works by making this a negative negative, the opposite of negative 3. And then we were supposed to generalize this with hk. I'll do this in blue so that you can see it stands out a little bit. Instead of using the point negative 6, 3, I'm going to use h and k. So everywhere I see this negative 6 and 3, I'm going to say x plus a negative 3 or minus a negative 3 would be a plus. So this would be minus h squared plus y minus k squared is equal to my radius squared. This, folks, is the general equation of a circle. And we'll synthesize that in our lesson. So the activity synthesis, here we're supposed to connect this to the circle and come up with the equation. So I'll do that now. Again, I'll put my xy on this graph. I'll make a right triangle out of this. In my coordinate that's missing in the x direction, we're at x. In the y direction, we're at k. So the length here in the x direction, all the way across is x, and I'm going to subtract from it my h. So I have x minus h squared. This is my x minus h. And Pythagorean theorem. This is y all the way down, and this is k. So if I subtract y from k, k from y, I get k minus y. So a squared plus b squared. This is Pythagorean theorem. A squared plus b squared is equal to c squared. So this is equal to my radius squared. Again, this is the general form of the equation of a circle. Just like you have for the equation of a line, y is equal to mx plus b, this is the form that defines a circle. It is not a function. It doesn't pass the vertical line test, but this is the equation. And the equation could be thought of as a point tester. If you have the radius or the center, hk, you have a point that has coordinates x and y, you could plug them in here. If you know the radius and it works, it's true, then it's on the circle. And conversely, if it's not true, then it's not on the circle. So you want to add this definition to this theorem to your reference chart. The circle with center hk and the radius r has the equation x minus h squared plus y minus k squared is equal to r squared. And then we have this graph. Can you describe this graph? When I ask for a description of the graph, what I'm looking for is what is its center, what is its radius. If you wanted to give me the equation, that would be good too. Not this equation. This is a different one. So here the center is at 2, -3. And the radius, I'm going to count on the grid, 1, 2, 3, 4, 5, 6. If I wanted to write the equation, I could use h and k as h and k is my 2, -3. And so I could put x minus 2 squared plus y minus -3 squared is equal to 6 squared. That would be another way to describe it. In the cool down, you're supposed to write the equation of these two circles. Here we have the center at 0, 0. So this is going to be x squared plus y squared is equal to the radius 8 squared. Here we have a radius of 4. I have x minus a -2, which is x plus 2 squared, plus y minus 4 squared is equal to 4 squared. And there is a summary of this lesson right here. You can read through it on your own. Good luck and success.